Jai Hind. Class 11 Chapter 2 Structure of Atom. Summary of the chapter. It means nodes. First, in this chapter there is Thomson model. It is also called plum pudding model. It is European dish, plum and pudding. So this model is Thomson's model. Plum pudding model is Thomson's model. Electrons are uniformly distributed in atom. This is the plum pudding model. So this is plum pudding where plus and minus are there. So electron and proton are in the equally distributed in plum pudding. So there is given spherical cloud of positive charge and there is negative charge. So all are embedded equally in the atom. So this was the atom's structure given by Thomson's model. So atom is neutral. Finally atom is neutral. Net positive charge on atom equal to net negative charge on electron. Next is mass of atom is uniformly distributed. Now drawback of this atom, electrons are not stationary, they are revolving around the nucleus. So what was the reason behind it? That was not explained by the Thomson. So in this plum pudding, electrons are stationary and electrons are not stationary given by other scientists. Second model is Rutherford model. Rutherford model is explained by alpha scattering experiment. In this alpha scattering experiment, there is given a diagram. This is the diagram. So there is the experimental setup, radioactive source, look the main important terms, and alpha particle getting scattered. So these are alpha particle going this side. Then there is a filter scatter and then beam of alpha particle. Beam of alpha particle is going out and there is a thin gold foil. The alpha particle going out from this foil and outside there is circular zinc screen. And after passing through the gold foil, zinc they are falling on the zinc screen. So this is alpha particle. Alpha particle means helium, He plus 2 ion. Observation. Most of the alpha particle pass and deflected. It means most of the alpha particle go straight. Next is a few alpha particle deflected at some angle. Third is a few 1 out of 2000 deflected at 180 degree. So 1 out of 2000, it means deflected 180 degree. It means the alpha particle goes to the gold foil and after falling it will collide and return back to the same path. Conclusion. Most of the part of the atom are vacant. So it means most of the part of atom is vacant. Vacant means empty. There is no matter. Atoms has some positive charge in it. Positive charge of the atom is concentrated in the nucleus. Due to 180 degree back of alpha particle, return back of alpha particle, we can say positive charge of atom is concentrated in nucleus. Electrons are revolving around nucleus and proton and neutron lies in the nucleus. So proton plus neutron equal to nucleons. Number of protons equal to number of electron equal to number of atomic. This is called atomic number. So atomic number is number of proton equal to number of electron because atom is neutral, therefore number of proton and electron are equal. Disadvantage or drawbacks. He could not explain the stability of atom. So Rutherford do not give the stability of atom. Second, he did not specify the number of orbits and the number of electrons present in each orbit. Third, he was unable to explain the line spectra given by every element. Next is electromagnetic radiation. These are the important terms related with this chapter. So it means when electrically charged particles move under acceleration, alternative electrical and magnetic field are generated and transmitted in form of waves called electromagnetic waves or electromagnetic radiation. In short form we called EMR. Next is wave nature of EMR. EMR means electromagnetic radiation, wave nature. According to the Maxwell's, accelerated charged particle produce electrical and magnetic field. And second point is electric field and magnetic field are perpendicular to each other and also perpendicular to the direction of propagation. Third point, electromagnetic radiation do not require any medium and they can travel in vacuum with the speed of light 3 into 10 to the power 8 meter per second. Important term name is wavelength. Symbol is lambda. This symbol is lambda, reverse inverted Y. So wavelength is linear distance between two consecutive crusts or between two consecutive troughs. It is generally expressed in terms of angstrom. Angstrom is written as A, capital A with small circle. So 1 angstrom is 10 to the power minus 10 meter. And we see the diagram. This is sine graph and this is top part called crust and bottom part is called trough, and between two consecutive crusts it is called wavelength, or between two consecutive trough it is called wavelength, and the top from the base or middle is called amplitude. So this is amplitude. Now next is frequency. And it is written by nu. This V-like structure is called nu. Number of waves passing through a point in 1 second is called frequency. Its unit is hertz and short form is Hz. Hertz means 1 upon second. So nu equal to c upon lambda. Lambda is wavelength, c is speed of light. So speed of light upon wavelength is called frequency. Next is velocity. Its symbol is c. Linear distance traveled by wave per second is called velocity. So velocity means linear distance traveled by wave in 1 second. Wave number of wavelengths per unit length. So it is 1 by lambda and mu bar. This is the symbol for wave number. In 1 meter length, how many waves are there? It is called wave number. Next is when the electromagnetic radiations are arranged in order of their increasing wavelength or decreasing frequencies, the spectrum obtained is called electromagnetic spectrum. And this spectrum, electromagnetic spectrum, is important. So this 2.7 figure in book is important, NCERT book. Next is very important numerical. 4 wavelength 5000 angstrom, calculate wave number and frequency. So wavelength given 5000 angstrom convert into meter. So 10 s power minus 10 we write in multiply of 5000. Now wave number is 1 by lambda. So 10 s power 5000 into 10 1 by lambda means this wave number we write in wavelength is write in denominator. So 10 s power 10 comes in the numerator and 5000 is in denominator. So after solution it gives 2 into 10 power 6 per meter. Frequency equal to c by lambda. C is 3 into 10 power 8. Lambda is 5 into 10 power minus 7. So dividing we get 6 into 10 power 14. Second minus 1 or 6 into 10 power 14 hertz. Next is drawbacks of wave nature of EMR, electromagnetic radiation. Drawback means disadvantage. It cannot explain black body radiation and photoelectric effect. Next is particle nature of electromagnetic radiation. Planck's quantum theory. The radiant energy absorbed or emitted from body not continuously but discontinuously in the form of energy packets or it is called quantum. Quantum is energy packets. It means it is discrete form of energy. In case of light, these packets are called photons. Energy of photons is directly proportional to frequency. That means E is directly proportional to mu. So E equal to h mu. H is Planck constant. Planck constant's value is 6.62 into 10 to the power minus 34 joule second. As we know, nu equal to c by lambda. Nu means frequency equal to speed of light upon wavelength. So E equal to hc upon lambda because E equal to h nu. So we replace with c upon lambda. So there are energy of 1 photons. So for n photon we multiply by n. So it become total energy equal to nh mu or nhc upon lambda. This is total n photons energy. Next topic is black body radiation. So K3b कुछ काम की बात. Black body radiation. It means it is important terms. So black body means the ideal body that emits and absorbs radiations of all frequencies is called black body, and the radiation emitted by such body is called black body radiation. Next is photoelectric effect. When photons of sufficient energy hits the metal surface, then the electrons comes out of the metal surface and there is no time gap between striking of photon and emission of electron. There is a characteristics minimum frequency required called threshold frequency. It is represented by mu naught. It is threshold frequency. Next is minimum energy of photon required to remove an electron is called wave function W naught. So W naught equal to h mu naught. Next is kinetic energy of electron increase with increase in frequency of photon. So E equal to W naught plus Ke. E equal to h nu equal to h nu naught plus kinetic energy formula is half m v square. So m is mass of electron because electron is moving and vs is v is velocity. So taking common and transposing to other side, kinetic energy equal to h mu minus mu naught or w equal to h mu naught. So when now important problem, when electromagnetic radiation of wavelength 310 nanometer fall on the surface of sodium, the electrons are emitted with kinetic energy 1.5 electron volt. Calculate the work function of sodium in terms of electron volt. So solution is, here is given x lambda equal to wavelength equal to 310 nanometer, or kinetic energy 1.5 electron volt. So we use formula E equal to W naught plus KE, E equal to H nu and equal to W naught plus KE. So W naught equal to, we transpose KE other side, so it become H mu minus KE. So W naught equal to HC upon lambda minus KE, and we replace the value of H, C and lambda, and kinetic energy also given. So we get final value 2.5 electron volt. So here after calculate, we replace the value. The Planck constant H, its value we have to remember. So value of H is 6.6 into 10 to the minus 34. C is 3 into 10 to the power 8. Lambda is given 310 nanometer. And we replace and solve, and we convert H and into C into electron volt angstrom. So here H is 6.6 into 10 to the minus 34, C into 3 into 10 to the minus 3 into 10 to the power 8, and electron volt, due to electron volt, this value we divide by 1.6 into 10 to the minus 19, and lambda is denominator is given 310 nanometer. In angstrom it is 3100 angstrom, and we solve it, we get 2.5 electron volt. Next is dual nature of electromagnetic radiation. Dual nature of electromagnetic radiation. This is important. Dual means two nature. So what means two nature? To explain reflection, refraction, diffraction, etc. Light has been considered as a wave where to explain the photoelectric effect. Einstein considered it to be the made up of tiny particles called photons. So photons is tiny particle, and these are energy particle. In other words, light is kind of radiation, exhibits dual behavior. So light shows dual behavior. Example, that is wave as well as particle behavior. So two nature, wave as well as particle behavior shows by light. Such a wave like as well as particle like nature of radiation is known as dual nature of radiation. Next is K3B, कुछ काम की बात. First, the splitting of light into series of color band is known as dispersion. So white light into 7 color divide is called dispersion, and the series of color band is called spectrum. Two types of spectrum is there: emission spectrum, absorption spectrum. It is like the photoelectric negative of an emission spectrum. Photographic negative. Photographic negative means real. When we use photograph in photo studio, they use photographic negative. It means they need to develop photo from this reel. So this photographic negative of an emission spectrum like structure is there in absorption. A continuum of radiation pass through sample which absorbs radiation of certain wavelength. The missing wavelength, which correspond to the radiation absorbed by the matter, leave dark spaces in the bright continuous spectrum. This is the notes summary. There is the numerical important problem. Next is their important model, Bohr model, that we discussed later. there is in energy of electron formula. This chapter is a long chapter in the chemistry. So these are the notes. Next is calculation frequency formula. Next is ionization energy formula. Next, Heisenberg uncertainty principle. There is the numerical. Next is reason for Bohr's model failure. Failing, it means drawback of Bohr's model or failing of Bohr's model reason. Next is atomic orbital theory points, orbit and orbitals. So Heisenberg uncertainty principle comes after. Next is quantum number, important topic for this chapter. Quantum number. So there is orbit number, subshell and orbital. Next is quantum number. 4 type of quantum number: principal, azimuth, magnetic, and last is spin quantum number. 4 types of quantum number is there. Next is energy of orbitals. Theory part notes. And next important points on electron: mass of electron, charge of electron, proton mass and proton charge. Next is neutron's mass and charge. Charge is 0 in neutron. Next, atomic number definition, mass number definition. Next is representation of nucleus, how we write atom. Next is discovery of proton theory. Next is discovery of neutron theory. Next, limitation of Thomson's atomic model. Thomson has discussed earlier, but there are few points, important points that left. This is the notes in this Thomson model. Limitations. Next is series, Lyman series, Palmer series, Parson, bracket Fund. And these are the notes, ended total notes of this chapter 2. I hope you will write in copy and revise it. Okay.